I just realized when I was looking back at this one, I had boxed the wrong answer. They want to know what's missing. I boxed the final answer, which they already gave us. So you don't want that box. This is what you will type into Alex when you're doing your homework. What's missing to make the perfect 5? Okay, let's go ahead and see how you did on the 2 problems you did on your own. So I see here we have the 4th root of x squared and y cubed. And we need to know what's missing to make that perfect 4s. So I look and say I have 2 x's and I need 4, so I need 2 more. I have 3 y's, I need 4, so I need 1 more y. So that's going to give me, and remember, this is your answer, but then you just finish the problem just to make sure you get what they say. So now multiplying those, we'll get the 4th root of, let me move this over just a little bit. X to the 4th, y to the 3 plus 1, 4, which gives us our final answer, or not final answer, what gives us our check of 4 divided by 4, x to the 1st, 4 divided by 4, y to the 1st, outside the radical. And that's what we needed to end up with. Okay, this last one, it looks like it's the 7th root. So we know whenever there's a number, we have to break it down. And this is the one we love because we have it memorized. 2 to the 5th, x to the 2nd, y to the 1st. So now we need to decide how many of each one we need to make it perfect. Perfect meaning perfect powers of 7 so that everything pops out of the radical. We have 5 2's, that means we need 2 more. We have 2 x's, that means we need 5 more x's. And we have 1 y, which means we need 6 more y's. So this is the missing radicand. And to check it, we just finish working it out. So it'll be the 7th root of, now we have 5 plus 2, 7 2's. 2 plus 5, 7 x's. 1 plus 6, 7 y's. Now that they're all perfect powers of 7, 7 divided by 7, 2 to the 1st pops out. 7 divided by 7, x to the 1st pops out. 7 divided by 7, y to the 1st pops out. And you can see that is what we were supposed to get, 2xy. So that is what it's missing to make it perfect powers. So now we're going to move on to page 7 and see why we had to learn this. So we're learning it in order to get rid of the radicals in the denominator of a fraction. So I have an example up here for you to look at. So let's read through the box here. So to remove the radical from a denominator of nth root, we need an nth power. So we're going to be using the property n divided by n pops the a out as a to the 1st. So here's a great example. So we have 3 over the square root of xy. So we say, wow, that is a power of 2, so we need 2 of everything. Well, right now we just have 1 of everything, so we're going to have to multiply by the square root of xy, which will make it have 2 x's, whoa, that's a bad y, and 2 y's, and then we multiply by the square root of xy, because whatever we do to the numerator, we always have to do to the denominator, right? And I just put it in a different color so you could see we're adding that. But this is really 1. Anything divided by itself is 1. So when we multiply something by 1, we may be changing its looks, but we're not changing the value. So now we'll have 2 x's and 2 y's. So my new numerator will be 3 on the outside, xy underneath, and my new denominator will be square root of 1 plus 1, x squared, 1 plus 1, y squared, which then we can go 2 divided by 2, x to the first, 2 divided by 2, y to the first, and we now have no denominator with a radical. So that's called rationalizing the denominator. We remove the denominator from the original problem because we learned a couple pages back on page 1 that we can never leave a radical in the denominator of a fraction. It's okay to leave one in the numerator, but never in the denominator. And we can do the same thing with other powers. So nothing's common here. So notice my first step was I broke it up into 2 separate radicals. Cube root of 5 over the cube root of 2 to the first, y to the first. So then we have to multiply this original fraction by what's missing. Well, we had 1, 2, and we need 3, so I added in 2 2's. We had 2 x's, I need 3, so I added in an x. We have 1 y, I need 3, so 2 more. And notice this is always the same. This is your 1. Whatever you do to the denominator, make sure you do the same thing to the numerator. So this is what's the missing radicand in order to make them all perfect. So my new numerator is going to be cube root 4 times 5, 20, an x, and 2 y's. My new denominator is going to be 3 2's, 3 x's, and 3 y's under a cube root, which we know because they're all powers of 3, they will pop out. 3 divided by 3, 2 to the first, 3 divided by 3, 2 to the first, and 3 divided by 3, y to the first. So notice my final answer doesn't have any triples. 20 is 4 and 5, which is 225. No triple there, no triple there. And my denominator has no radical because we made it perfect powers of 3 by multiplying by what was missing. So there's 2 from this section on your test. Letter B is one of them that will be on your test, and letter C is the other one. So let's go ahead and highlight those 2. And if you're keeping up with your practice test, this would be number 8 and number 9 on your practice test. So this is number 8 on the test, and this is number 9 on the test. Okay, so let's see how we do here. So 49 and 20 have no factors in common. So we're going to break those up into 2 separate radicals like the division property of radicals allows us to do. And we get square root 49. And I know I'm going to have to break this down, so let's go ahead and break down the 20 right now. It's 4 and 5, which is 2, 2, 5. So now we can circle our perfects. 49's perfect, right? Because it's 2 7's. And then we have 2 2's down here. So that's going to leave us with, and we always simplify first before we remove the radical. We never remove the radical first. We simplify, then remove the radical just like we did above. So the square root of 49, like I said, it's 2 7's. 2 7's pop out as a single 7, no radical. 2 2's pop out as a single 2, and then we have radical 5. So this is really our problem. So now that it's simplified, now we look and go, oh, wait a minute, I can't leave a radical in the denominator. So how do I get rid of that radical? I make perfect, in this case, it will be pairs. So I need 2 5's in order for that 5 to come out of the radical. So I only have 1 5, so let's multiply by square root 5. But whatever we do down there, we need to do up here as well. And so does everybody understand why we did that? We needed to make 2 5s for that 5 to pop out. So now we have 7 radical 5 over 2, and we can make it radical 25 if we want. And so that turns into 7 radical 5 over 2 times 2 5s come out as a single 5, so 2 times 5, 10. So our answer would be 7 radical 5 over 10. So notice my radical can't be simplified. It's a single 5. Nothing's common between 7 and 10. And I have no radical in the denominator. And you'll notice that A and B are very much alike, so you can study actually both of those for number 8 on the test. They're very similar. I think the same thing is true with C and E, so you could study both of those as well. Okay, so maybe it's time to shut off the video and do letter B on your own, and then we can come back and compare answers. Okay, so the first thing I notice as I'm doing this is that nothing's common. 6 and 25 have no common factors, so that's my hint to break it up into 2 separate radicals. So 6 is 2 and 3, there's no pairs. But 25 is 2 5s. And remember how on x cubed, we want it to be a power of 2, so we'll make it x squared and x. So 2 5s for 25. 3's not divisible by 2, so we go down 1 and do 2 x's and then a leftover x. Or you could have written x, x, x. Either way. So I see that we have some things that are going to come out. We're looking for pairs, so here's a pair and here's a pair. And remember, 2 things underneath come out as a single outside. So this would be square root of 6 over, that comes out as 5, that comes out as x, so we'd have 5x, and then under the radical, just x. So 2 5s come out as a single 5, 2 x's come out as a single x, and now we're actually ready to start the problem. So we have everything simplified. So now we look and go, well, the 6 can't be broke down, but oh man, I can't leave that radical in the denominator. Right now I have 1x. In order to pop out of the radical, since it's a square root, I need 2 x's. So my missing radicand is 1 more x. So in order to get that to pop out, I need 2, so let's add in 1 more. But whatever I do to the denominator, I have to do the exact same thing to the numerator. So what do we have now? In the numerator, they're both under the radical, so we're allowed to multiply them, so that would be 6x. In the denominator, we have 5x outside and x squared inside. We made our perfect pair, so that's going to pop out on the next step, right? So we have square root 6x over 5x times, remember there's an imaginary times there, 2 x's come out as a single x, so that will give us our final answer of square root 6x over 5x squared. Square root 6x can't be simplified. There's no pairs. And 5x squared, no radicals down there. So we are done. So we'll stop here and pick up on letter C in the next video.